Right, so the second half of this unit shifts our focus to some figures in geometry where we will be finding the perimeter and area. And in order to find perimeter and area of some of these figures, we use formulas, which is an equation that shows the relationship between two different variables or multiple different variables. Like I said earlier, perimeter and area, they're measurements that can be found using these formulas. Let's start with perimeter. The perimeter of a plane is the sum of the side lengths, the length all the way around. You can see an example down here. A fence, maybe a fence that's used to fence in a property. That's the length all the way around a property, while area is the number of square units that cover a figure. And a unit of area that we sometimes use would be acres. So you can think of an acre as the amount of square units that cover, well, there's 43,560 square feet in 1 acre. And that's about the size of half of a soccer field. You can see in that example there. Let's start with some of our basic figures, list some properties and how we would find the perimeter and area of each of these figures. So these are all plane figures, two-dimensional, a square and a rectangle, 4 sides, two-dimensional, 2D meaning flat. A square has 4 congruent sides and 4 right angles, while a rectangle has 4 right angles and not 4 congruent sides, but 2 pairs, or we can just say opposite sides, are congruent. And then for our triangle is our two-dimensional figure that has 3 sides. And really our only properties of a triangle would be 3 sides, 3 angles. There could be different relationships with those side and angles, but for now, just our most basic definition, 3 sides and 3 angles. And then you can zoom in here and see these congruent markings that we have. If there's 1 marking, 2 marks, and then 3 marks here, it's showing you all the side lengths are different for this triangle. You can see for your rectangle, opposite sides are congruent, right? These opposite segments with the same number of congruent markings. And then for a square, 1 mark on each shows you all 4 sides are congruent. Let's talk about our formulas for perimeter and area. Easy way to find the perimeter of a square, if all the sides are the same, we can just multiply one of the side lengths by 4. 4 times a side length, or 4s. S stands for side length. If we want to find area, the number of square units inside a square, we would just multiply base and height, or side times side. And because the sides are the same, we can just multiply. You can just say side squared. For a rectangle, because opposite sides are congruent, for perimeter, we can take the lengths and multiply by 2, and then add it to the width, doubled, to get our perimeter. Or you could just add all 4 sides. For area, length times width, you guys have seen that formula before, or base times height, both mean the same thing, length and width, base and height, they meet at right angles. For perimeter of a triangle, no special formula here, we just need to sum all 3 sides, meaning add all them together. And then for area, 1/2 base times height. As you can think of a triangle as half a rectangle or half a square. So we use the same formula, base times height, and then we just cut it in half. The one thing you need to be careful with for base and height of a triangle, because triangles can be in multiple different shapes, you need to look for base and height meeting at a right angle, okay? So the vertex of the height is going to form a right angle with the base. Base and height meet at right angles. And then just notice that the height can sometimes be the side. So over here, this example I showed you, the base and the height were the sides. That's the same example right here. The height can sometimes be inside the triangle. If the sides don't meet at a 90-degree angle, it can be inside, or it can be outside. This example over here, height outside, inside, or it's one of the sides of a triangle. And you'll see plenty of examples like that on the back page. So let's go ahead and flip that over. I'm going to find the perimeter and area of some of these two-dimensional figures, these plane figures. Let's do a rectangle together. And then we'll do two triangles together, okay? Let's start with A, perimeter and area. For perimeter, if opposite sides are congruent in a rectangle, look at your congruent markings. You can just add up all the sides. 10 plus 10 gets us 20 inches. For area, base times height or length times width. 6 times 4 just gets us 24. And then don't forget, we're talking about the number of square units that fit inside this figure. So we would say 24 inches squared. Perimeter, just 20 inches. Okay, let's go look at example D. It's okay if we have expressions instead of whole numbers representing our lengths. So for perimeter, we can just add all these expressions, x plus 4 plus 5x plus 6. And then we're just combining like terms, 5x and x, 4 and 6, we get 6x plus 10. No units here, it's just the expression that represents the perimeter of this triangle. And then for area, okay, be really careful with area of triangles. The base and the height need to meet at the 90-degree angle. So in this example, the base and the height are, the height's the side of the triangle because this is a right triangle. So we would say 6 times x plus 4. Don't forget to distribute. We get 6x plus 24 for our area. All right, let's try one more together for E. Hopefully you notice multiple lengths here. The 3 lengths we want to use for perimeter would be the 3 sides of the triangle. So 14 plus 8 plus 16, which gets us a perimeter of 38 meters. For area, because it's not a right triangle, the base and the height, they're not going to be 2 sides. So instead, hopefully you can see that this side and this dotted line inside, these meet at a 90-degree angle. So this would be your base and your height. And we would say 1/2 16 times 7, half of 16 is 8, and 8 times 7 gets us 56 meters squared. Okay, why don't you try and find the perimeter and area of example B. Perimeter should have been 12 centimeters, and area should have been 6 centimeters squared. Why don't you do the same for example C? Find the perimeter and area of this square. Again, this was a square because 4 right angles and all 4 sides are the same length. Perimeter would have been 18 4 times, so 72 miles. And area would have been 18 squared, 324 square miles that fit inside of this square. Last one, F. Give F a try. Find the perimeter and area. Okay, for perimeter, there's actually not enough information because this is your triangle. you're missing this side length here, x. And there's no way we can find that side length, so for perimeter, you could just say not enough information. For area, we did have enough information because this 5 and this 15.4, these meet at a 90-degree angle. So this was the example where base and height meet outside of the triangle. So your area should have been 1/2 5 times 15.4, which would have gotten you 38.5 centimeters squared. All right, let's finish up talking about circles. Circles are also two-dimensional plane figures. There's a little more vocabulary we're going to introduce here, which you might have heard before. The diameter of a circle, it's a segment. It's a segment because it has two endpoints that are on the outside of the circle, and it passes through the center. That's probably the most important part. So it's passing through the center here. The two endpoints are on the outside of the circle. A radius is another segment. A radius is a segment whose endpoints are, one of the endpoints is the center, which you can see right here for your radius, and another endpoint is somewhere on the circle. And then finally, circumference. The circumference is the length or the distance all the way around the circle, just like perimeter, but for a circle. Our definition of a circle is, or our one property, or one and only property, is that every point on the circle is equidistant, meaning of equal distance from the center. Okay, and because of that relationship, we have a relationship between the radius and the length all the way around. And that relationship uses this irrational number called pi. So pi just represents the ratio of the radius to the circumference as it changes in size. So the circumference is always going to be 2 pi r. If you remember pi, just let's put the definition up here. It's the ratio of a circle's circumference to its diameter. So because it's the ratio of a circle's circumference to its diameter, that's why we need this 2 in our formula for circumference, because we need to double our radius to get our diameter. And this means the circumference is always going to be 3.14 or about, that's what pi equals, a longer irrational number that we're not going to list out, about 3.14 times the length of the diameter. For area equals pi r squared. Okay, so taking the radius and squaring, then multiplying by pi. Let's try a couple examples here. Let's try B. Let's try A and B together, and then you can finish with C on your own. Circumference. Circumference, if the directions don't say leave in terms of pi, we're going to go ahead and multiply it out. So our radius is 14. We need to double that radius to get 28 to multiply by pi. That's what this 2r stands for. And then on your calculator, you have an option for pi. You can go ahead and hit 28 pi, punch that in, we get 88 meters. It's circumference, so it's just length around. We leave it as 88 meters. For area, we already have the radius, so we just need to punch in our pi radius squared, and we get 615.8 meters squared. Practice using your calculator. Practice finding that pi symbol, pi on your calculator. I will show you in class where it's located, but it's actually just above one of those buttons. You can press second and get to pi on your calculator. Let's finish with B. And then you can try C on your own. Circumference, again, you have a radius of 9, so we need to double that radius and multiply by pi. We get a circumference of 56.5 meters. And then for area would be pi times my radius squared. You get 254.5 meters squared. Okay, why don't you guys go ahead and try example C on your own, and we'll check your solutions in just a sec. Circumference, we should have had 37.7 feet. You were already given your diameter, so you just needed to multiply 12 times pi. Area, you didn't have your radius yet. So for area, make sure you used a radius of 6. If the diameter is 12, the radius is going to be half of that, which is 6. So our area should equal pi times 6 squared. Plug that into your calculator and you get 113.1 feet squared. And then really quickly, if you're on your calculator and you're looking for pi, you would just press second and then this up arrow, and that will get you your pi symbol. This is on your calculator. Okay. I will show you in class that Desmos just has a pi symbol on that calculator. So it's a nice, easy, user-friendly calculator you can use on Google to punch in these calculations and work on rounding to whatever the problem says. Nearest tenth, nearest whole number. It'll change from problem to problem. Great work. I'll answer any questions you have in class.